So let's say that we have a straight line with the points A and B. How do I find the distance? How do I find the distance between A and B? In other words, how do I find the shortest distance or the length of this line segment AB? Now we've learned earlier something called Pythagoras' theorem. In other words, we know that the change in x from A and B is this horizontal line here, whereas the change in y from A to B is the length of this vertical line over here. So this is the change in y. And we know that the length of this line segment is simply the hypotenuse. If we have a right angled triangle, then the distance AB squared is the change in x squared plus the change in y squared. So let's write that down, that the distance AB squared is the change in x, the whole thing squared, plus the change in y, the whole thing squared. Now the change in x from A to B, is simply the difference between x values. So the change in x can be rewritten as x2 minus x1, the whole thing squared. And the change in y is the difference in y values. So y2 minus y1, the whole thing squared. So that is the distance AB, the whole thing squared. Now, to find the distance AB, all I have to do is take the square root of these values, which is the square root of x2 minus x1, the whole thing squared, plus y2 minus y1, the whole thing squared. So if I have any two given points, x2 comma y2 and x1 comma y1, the distance between those 2 points, or the length of the line segment that connects these 2 points, is simply this. So now let's look at a worked example. They've told us that the points A and B lie on a straight line, and they want us to find the distance AB. Now, let's first quickly draw a sketch. The point A, which has coordinates 4, comma minus 5, and the point B, which has coordinates minus 4, comma 1. This is the point B, and this over here is the point A. And let's draw a straight line through this. So now they want us to find the length of this line segment AB that passes through both of these points. Now, we know from our calculations, that the change in x, the whole thing squared, plus the change in y, the whole thing squared, is equal to the distance squared. So the change in y, the whole thing squared, plus the change in x, the whole thing squared, is equal to the distance squared. So the distance between A and B, then, what we just calculated, was the change in x squared, which is x2 minus x1, the whole thing squared, plus y2 minus y1, the whole thing squared. So therefore, the distance between A and B then can be equal to the square root of, and now let's take A as x1 comma y1 and B as x2 comma y2. So x2 is minus 4 and x1 is 4, so minus 4 minus 4, the whole thing squared, plus y2, which is 1 minus 5, the whole thing squared. So then the distance AB is equal to the square root of minus 8 squared plus 6 squared. And hence the distance AB is equal to the square root of 64 plus 36, which is equal to the square root of 100, which is equal to 10. So this distance AB over here is equal to 10.